Hi class, Miss Stevens here, video number 5 in our Industrial Revolution unit. This time we're having a look at the impact of innovations and new inventions. So we previously had a look at the innovations of the agricultural revolution in Britain, but this was only the beginning. There were lots of amazing innovations that characterised this period and which also enabled the Industrial Revolution to happen. So new inventions and innovations that centred on the production of new energy and new industrial machinery is what we're going to be having a look at. These created faster and more efficient means of production, which result in the rise of factories and consumerism that characterise this period. So small-scale home-run production was outmoded, and machines eventually replaced human or manual labour. And of course, the impact on the economy and society of this is significant. First thing we're going to be having a look at is the steam engine. So this is said to be the greatest technological advancement of the Industrial Revolution. Steam engines produce the power needed to drive machinery and transport. They obviously save on labour, they increase production, and they enable the substitution of coal for more expensive fuels such as wood, which had previously been used extensively. The invention of the steam engine came about due to the rising demand for coal to heat homes and other buildings. Now, coal mines become deeper and deeper, and if you have a look at this image here, the angle of the track where the miners are going down deep into the shaft of the mine gives indication of just how deep it was. Now, this was taken in 1905, but it still gives you an idea. Now, as these mines get deeper, they end up filling with water. And over here I've got an image for you of some modern day miners down in a pit, and you can see the water dripping from the ceiling of the mine as it filters through the rocks. And eventually, if that wasn't pumped out, it would end up filling up the mine, which becomes obviously a big impediment to getting more coal out. So previously, water wheels and horses had been used to provide the power to drive the pumps that were pulling the water out. But as the pits get deeper, more power is needed, and these traditional methods aren't enough anymore. So we get the invention of the vertical pump. So in 1712, Thomas Newcomen invents a steam engine that produced vertical motion. In other words, it could drive something up and down, and this is ideal for driving a pump. If you have a look at this little animation, you can see that we have down the bottom a fire that's heating up water, creating steam. This valve here opens and closes, letting the steam out, which goes into this chamber here. It eventually cools, which causes it to create a little vacuum and pulls this section of the machine down. The water drains out here and is stored and returned back down. You can see that you've got a seesaw-like motion connected at a fulcrum in the centre, this section pulling down, this section over here pulling up, and that was attached to a chain down here which fed down into the mine. It was then attached to a pipe, and that was allowing the water to come back up to the surface through the weight of the machinery in a pulling motion. And you get a sense of the size of this machinery from this image here, a person giving us a little bit of a scale, and this particular Newcomen engine was built in about 1760. Here's the boiler where the water is, and here's the beam. So this invention means that for the first time water can be raised from a depth of over 50 metres. And the first example of this was in 1711, where they created one that replaced a team of 500 horses that had previously been used to pump water out of the mine. And eventually 75 of these Newcomen pumping machines were installed at mines in Britain, France, Holland, Sweden and Russia as well. And over the next 50 years, only a few small changes are made to this engine design, and it's a fantastic advancement and contributes to the Industrial Revolution. In 1778, however, another person named James Watt begins to investigate how he could adapt Newcomen's engine to drive a machine instead of just a pump. Now, he innovates and creates a new kind of design here, and it ends up using 75% less power. So obviously this is much preferable. They also have some clever marketing, which includes a payment system, and it means that mine owners can pay off their purchase of the machine from their savings from needing less coal over a period of 3 years. And this picture here is actually of one of the oldest working engines in the world. It's called the Smethwick engine, and it was brought into service in May 1779. It's now in Birmingham. And if you have a look here, the beam is now made of metal, and this particular one was made for drawing water back up a hill for 6 locks that were servicing a canal to enable a foundry to function. And this particular version here works on both a forward and a backward stroke, meaning that it can be reversed, unlike the previous version that Newcomen had designed. And eventually this is going to allow Watt to further innovate and figure out how to make it into a rotary engine, or something that will spin. So he's able to change the way the pistons and the beams were connected. And in 1781 he develops a gear system that converts the power of a vertical steam engine into a rotary motion, which turns the wheel instead of just pulling and pushing. So here's a little animation that shows how it can turn a wheel. So rather than just going up and down, there's a gear system over here that allows another wheel to be turned. So the Whitbread engine was the first rotative steam engine ever built in 1785, and it was originally installed in a brewery in London. Today, this engine here is actually held at the Powerhouse Museum in Sydney. After it was decommissioned in 1887, it was transferred to Australia. And what you can see in the centre here is what Watt termed the sun and planet gears. It's these small circles in the centre, and these are what turned the larger wheel, and that larger wheel was then connected to other machinery in the factory.